So this is my second presentation for the APS 162 Mathematics course, and the sum I've selected is sum number 57 from chapter 4 of the Briggs textbook. And reading the question, we obviously have to start off by making a diagram, and we might think of making a diagram that looks a little something like this. And we wouldn't be wrong because the diagonals technically do give us the shortest distance between BD and AC. However, it does not give us the shortest distance between BC and AD because BO plus OC is going to be greater than BC. So what we need to try and do is to make the sum of BO and OC get closer and closer to BC, and picking up from the hint which asks us to place 2 points inside the square, we can make a diagram that looks something like this. And this obviously makes much more sense than the previous diagram. So now that we have our diagram, we can move on to bringing a relationship between the various parts of the road and to find the length of our road system. Which brings us to this function. That's essentially the addition of all the bolded lines that have been shown in the diagram. And in order to try and build a relationship between these different line segments, that's AF and DF, GB and GC, we extend FG in such a way that the line that intersects AD and BC is a perpendicular bisector to both lines. And with that information, we also find that we have 4 triangles. And in these 4 triangles now, AE, ED, BH, and HC are equal. EF and GH are equal. They're both equal to X. And angles AEF, DEF, BHG, and CHG are also equal. So considering that in all 4 triangles we have a side angle and a side that are equal, we can use the SAS theorem of congruency to imply that AF equals FD equals BG equals GC. And this makes our job very much simpler because now all we have to do is find one of the sides in terms of X using the Pythagoras theorem, and that's what we do. That's how we find that AF equals DF equals CG equals BG equals root of X squared plus 1 upon 4. And to find FG is also extremely simple. Knowing that EH would be equal to 1, we subtract the 2 x's from the 1 and get 1 minus 2x. So now we have all the components of our function that we have found, and all that's remaining for us to do is to plug it all back into the original function for the length of the road system. And so this is what we get. So we get Lx is equal to 4 times root of x squared plus 1 upon 4. And we multiply by 4 because there were 4 line segments of the road that were equivalent, plus 1 minus 2x. And in order to find the minimum length of this particular road system, we are definitely going to have to find the derivative of this function. And so we take the derivative of both sides with respect to x, and using the chain rule on this term, we get 4 times half into 1 upon root of x squared plus 1 upon 4 into 2x minus 2. We can cancel 2's out. And we get this as our simplified derivative. And to find the extremum points, we're going to have to equate our derivative to 0, and that's what we do. Doing that, we can divide both sides by 2. And then we continue simplifying, and we see that because of denominator, we can multiply both sides by root of x squared plus 1 upon 4. And we then take the negative root of x squared plus 1 upon 4 to the other side and square both sides. And then bringing the x squared to the left-hand side, we get x is equal to plus minus 1 upon root 12. Now x being a length cannot be negative. It has to be greater than or equal to 0. So we can neglect the negative root and take the positive root and work with that. So x is equal to 1 upon root 12 is our extremum point. Now we have to verify whether or not it's a minima or a maxima. And for that we can use the number line. So as I've computed over here, I can plug x is equal to 0 into my derivative and I get a number that is negative. So my derivative is going to be negative in this particular range, for these values of x. And when I plug x is equal to 1, which is definitely going to be on the right hand side of x is equal to 1 upon root 12, I get a positive value for the derivative. So looking at the sign changes, we can say for sure that x is equal to 1 upon root 12 is a minima of this function. So all I have to do now is plug x is equal to 1 upon root 12 back into the function, and now I can compute it. So these are the steps that I would do. And over here, I can pull root 12 out common, which would give me a root of 36. So I pull the root 12 out of that, I get root 3 plus 1 in the numerator, and I can cancel the root 12s out, and I get root 3 plus 1. So writing the final answer statement, we have found that the length of the shortest road system that connects the houses using straight roads would have a length of root 3 plus 1 miles. Thank you.